Hey guys, hope you've all enjoyed your break and now you're ready to get back into the swing of things. Obviously doing this term a little bit different to normal, but as long as you're keeping up with the YouTube videos and all the work outlined on Compass, you'll be fine and you'll pass with flying colours. So the way this will work is I'll, for each lesson, upload a YouTube video on whatever the content is we're working on. All the work that you're required to do will be in the work guide, which will be uploaded on Compass. There'll also be a copy of the PDF for the textbook for this, if you don't have one. So we're just going to go straight into it really. Our first topic of the term being matrices. This will run over the first 3 or so weeks and finish with an assessment at the end. Now matrices, you might not have heard this topic before. The singular we call matrix. Unfortunately we're not going to be watching the movie, so no, we're not going to be studying Keanu Reeves or anything like that. Essentially what it is it's a rectangular array filled with numbers. At first we're just going to go through the basics. The numbers and the rectangles aren't going to have much meaning to them. But as we go through, we'll be looking at some more practical applications. So the way this works is, I'll just write down the notes. You guys can copy it as we go along. If I move too fast, you can obviously pause the video. And yeah, away we go. So as I said, a matrix is a rectangular array of numbers. So for an example, they're usually defined by a letter. We might have A equals our matrix here. So right now these numbers don't have any meaning or anything, this is just an example, but as I said, as we go and look at practical applications, we can look at how these can be applied to a variety of settings. Alright, so here we have a matrix A. It's got 6 numbers in it. Now in matrices, we call these numbers elements. So if you ever come across the term element, that's what it refers to. So we'll make a note of that. So elements refer to the numbers in a matrix. Alright, so 3, that's an element. 0, that's an element. -8, that's an element. Now all of these have a specific place in the matrix, alright? There's 2 main things we need to look at. We need to look at the rows of a matrix and the columns of a matrix. In this case, this has 2 rows and 3 columns. Now this refers to the order of a matrix. The order of a matrix is how many rows it has by how many columns it has. Because our matrix A here has 2 rows and 3 columns, what we say is that its order is a 2 by 3 matrix. And I'll show you how we write that. The way we do it is we write the number of rows, then we use an X, columns. So this doesn't mean the rows times by the number of columns, it simply means rows by columns. So e.g., matrix A, this one here, has an order of 2 by 3. Alright, now each one of these elements can be described with a specific notation. So what that means is we could have A, representing matrix A, and then what we have is some small numbers that might be 2, 1. What that means is it's asking what the element is in matrix A in the second row and the first column. So if we write that down as an example, A, that represents the matrix. M, I'm just using to represent the number of rows, or the row number, I should say. And N represents the column number. So let's look at some examples. Say we've got a matrix. It's defined by, we'll say D. And it has some elements in it. All right, so say we want to answer some questions about this matrix. First of all, its order. All right, look at the number of rows. 3 rows, 2 columns. Therefore, its order is 3 by 2. Now, if we wanted to find some of the elements, let's say, all right, question A asks for the element that's in D, 2, 2. And B wants the element in D, 3, 1. All right. Okay. So this means, all right, what element or what number can be found in matrix D in the second row and second column? All right, so we look at matrix D. The D is important because we might have 5 or 6 matrices labeled A, B, C, D, E, F, and this will tell us which matrix we actually need to look at. So second row, we go down to the second row, all right, 4 and 3, and then the second column. All right, so if you look at that, where they intersect, number 3, so the element in D22 is simply 3. Part B, matrix D again, yep. Third row, first column. All right, look at those, where they intersect, we get -1. And that's all it is. It's just about identifying which of the elements can be found in that specific location. Remember, if you have any questions about any of this content, that's what the Google Classroom has been set up for. If you haven't signed up to the Google Classroom yet, check your email history. It'll be in there from a couple of weeks ago. Make sure you sign up. That's where you can ask questions to clarify any content on. All right, now, next part is we've got some types of matrices. So subheading. Won't fit too much here. Different types of matrices. So we've been over order, we've been over defining, we've been over elements. Now we have different types, and these are pretty straightforward. They're pretty easy to identify. First one we might look at is a square matrix. Pretty straightforward. It's literally in the shape of a square, meaning that the rows and the columns are the same number. We haven't done any examples here yet, but an example would be a 2 by 2 matrix, a 3 by 3, a 4 by 4. It's where the number of rows and columns are the same. All right, I'm out of room here, so I'm going to get you guys to draw me one. It can be a 2 by 2, it can be a 3 by 3, it can technically be a 1 by 1. Doesn't really matter. Draw me up a square matrix. All right, I'm going to flip the board over. If you haven't had time to do that yet, pause the video now and you can do that. All right, we also have what's called a column matrix. They're pretty straightforward. They're just a matrix or a set of matrices that have just one column. example. This matrix contains only one column, therefore it's a column matrix. Next one. I'm hoping most of you will be able to guess what the definition of this one is. A matrix that contains just one row. Each of these contain 3 elements. We have a 3 by 1 and a 1 by 3. So those are the most basic matrices that we're going to be studying. A couple other different types. We have what's called an identity matrix. Right now these won't seem important, but when we get to some of the more advanced concepts, we'll be looking at them quite a lot. Hopefully some of you remember them from year 10. Identity matrices are always square matrices. So it's a type of square matrix. Alright, so they are square matrix. It has a diagonal of 1s and the rest of the numbers are 0. So as a couple of examples to show you for them. One thing I forgot to mention, I didn't write it down, is that they're typically denoted by an I. So if you ever see I, that usually refers to a type of identity matrix. So always a square matrix. If I do the 2 by 2, it'll look like this. The diagonal of 1s always stops in the top left and then goes down, and then the rest are 0. This is basically the matrix equivalent of the number 1, which we'll be using quite a lot down the track when we're looking at inverses and some more advanced concepts. If you were looking at the 3 by 3, diagonal of 1s, rest of the elements are 0. For the first part of the first exercise, it's just about identifying what the identity matrices are, not actually doing any calculations or anything with them yet. And just the last type of matrix that I'll do the definition of, another pretty straightforward one, is the 0 matrix. Again, pretty straightforward. It's a square matrix. Where all the elements are 0. So they're always a square matrix as well. They're basically the matrix equivalent of the number 0. One other thing I want to go over is This won't take too long. Those of you that did Year 10 Standard would have done graphs and networks as well, back in Jumpstart, a year and a half ago now, so you might be a little bit fuzzy on some of the details, but Matrices has a lot of crossover with graphs and networks, and that's going to be another concept that we're going to study with this year. They are basically two different ways of representing the same information. One in matrix form, obviously, and another in the graph and network form. What I want to go over quickly is what's called an adjacency matrix. So what this is, and hopefully some of you remember it that did Year 10 Standard. It's a way of representing the information in a graph. So say I did a pretty basic graph. Those of you that did Year 10 Standard, hopefully you can remember what these look like. Alright, you've got your vertices, they're the dots, edges connecting them up. So an adjacency matrix that would represent this information. It's always a square matrix, and depending on how many vertices are, depending on its order. There's 4 vertices here, so its order is going to be 4 by 4. Now typically we label the sides of an adjacency matrix, like so. Now we need to fill in the elements. Now, the elements, the numbers in there represent how many connections there are between each vertex. So for an example, it's how you can get to each vertex for traveling only along one edge. So from A to A, there's no way to do that traveling on one edge, so that would be represented with a 0. Now A to B, there's 2 edges connecting them, so there's 2 ways to get from A to B, so we represent that with a 2. You can also write the same here because it's not directional, meaning you can go in both directions, so it's going to be the same number. A to C is 1. A to D, there's no way to get from A to D traveling along only one edge. All right, and then we just go through and do this until we've filled out a matrix. B to B is 0, B to C is 1, B to D is also 1, C to C is 0, C to D is 1, and D to D is also 0. And that's our adjacency matrix. So that's pretty much all the content for exercise 4.2. There is a few little questions in there that are a bit more practical, but they use the same skills that we've gone over here, just interpreting what some of the numbers actually mean in context in the questions. So now look at the work guide that's in the class newsfeed on Compass. Have a go at exercise 4.2 questions. With these ones, what I would do is start the questions first, and then if you're still having some difficulty, make sure you post on the Google Classroom. I'll be there for the whole period for the lesson, answering your questions. Don't email me personally because it's good for everyone to see your responses in the Google Classroom, because frequently people have difficulty with the same thing. So just to recap, all our lessons will be filmed like this. That will be up on Compass for you to access. Then all the resources will be down the bottom. So your work guide and your PDF.